In this system, we want to demonstrate a circuit of a parallel system. We got a supply voltage of 10 volts and we got 3 loads of 3 resistors. The first resistor is 20 ohm, the next one is 10 ohm and the last one is 5 ohm. We have 3 switches so we can connect and disconnect the different loads. And for all the loads, we measure the current at H and we also measure the total current. You can see that for the supply system, the ammeter and switches, we have indication of how many ohms there are in the system. We set it to 0 ohm because we just want to find out about the voltage and resistance in a parallel circuit and the current. The first load was 20 ohm, so we got 10 volts and 20 ohm. It should give us a current of 0.5 amp. We try to connect and we can see that the current is 0.5 amp. The next one, we got 10 volts and 10 ohm. It should give a current of 1 amp. And it is true. The last one, we have 5 ohm. So we have a 10 volts and 5 ohm. It should give a current of 2 amp. 2.00, 2.00 amp. Now we'll try to connect both 20 ohm and 10 ohm, and we got a half amp and 1 amp, and totally it should give 1.5 amp. It seems to be correct, and if we just connect the last resistance of 5 ohm, you should add furthermore 2 amp, and totally we got 3.5 amp. So we got 10 volt, 3.5 amp, and thereby actually we can calculate equivalent of all these 3 resistors, because we got the supply voltage and the current. So we can calculate if we just have one resistor for all these 3 resistors instead. The voltage was 10 volt and the current was 3.5, and it gives us a total resistance of 2.857 ohm. If we look at the circuit for the parallel circuit, we can see that total current for a parallel circuit is the current for every load in a circuit. Here we got load 1, 2 and 3, but we can put on any more loads if we want that. Here we got the current for the parallel circuit, and the total current for the parallel circuit is equal to the sum of the 3 circuits we have in parallel. Circuit number 1, 2 and 3. We could add some more circuits if we got that, but in this system we only got 3. Instead of the current for the parallel circuit, we have the voltage divided by the resistance of the parallel circuit. The equivalent resistor of 2.857 ohm, and this actually current or voltage divided by total resistance is equal to the sum of the currents. And instead of the current we can write that it is the voltage divided by resistor for circuit number 1 plus the voltage divided by the resistor for circuit number 2 and plus the voltage divided by the resistor for load number 3 and so on. Maybe you can remember that instead of divide the resistance, we can multiply by J, and that's the conductance for the resistor, because the resistance and conductance is reciprocal of each other. So we just can set the voltage time the conductance for the total parallel circuit is equal to the voltage time the conduction for load number 1 and load number 2 and load number 3 and so on. Since we multiply with the voltage all places, we can get rid of the voltage, and we just said that the conduction for the total parallel circuit is the conduction for load number 1 plus the conductance for load number 2 plus the conductance for load number 3 and so on. Now we can go back and say that the conductance is the reciprocal of the resistance. So it means that 1 divided by Rp for parallel is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 and so on. Actually, we can make that sometime before, because from line number 2 we can go down here if we just set it up here that the voltage is 1 volt. If we want to calculate the total resistance for the parallel circuit, we just can take the reciprocal of the value up here or over here. So it means that we just can take the reciprocal of this 3 resistors in reciprocal added together. So it gives us 1 divided by and then the sum of the reciprocal of all the resistors. Let's try to calculate the system. The first resistor was 20 ohm. So 20, and the key for reciprocal is above number 9, 1 divided by x. So 1 divided by 20 gives 0.05. The next resistor is 10 ohm and reciprocal. And finally 5 reciprocal. And these we have to add together. And then finally take the reciprocal to get the parallel resistance. So plus plus and 1 divided by x reciprocal, we got the same value as before, 2.857. So we can try to change this value to 2.857 and see if the total current will be 3.5 amp. We can see that it is 3.49 amp, but it is because that the value for the resistance is not exactly 2.857 ohm, but 2.86 ohm. So the formula for parallel circuit and an equivalent of the total parallel resistance seems to be correct.